Here are the answers for the section 6-8 homework using graphs of quadratic functions. For question 1, we're given two different quadratic functions, x squared equals 3 and x squared equals 7. We're asked to solve these equations, but for our technique, we're going to use graphing. The way that graphing technique works is to treat each side of the equation separately. So take the left side of this equation and graph the function y equals x squared. Then on the same grid, graph the function y equals 3. We're going to do question B on the same graph because notice that the left side of this is also y equals x squared. It's the same parabola. The other function we'll graph is y equals 7, a horizontal line crossing y at 7. Okay, let's graph the y equals x squared part. We know from experience that that is a parabola, and the vertex is 0, 0. When x is 1, y is 1. So there's a dot here and a corresponding dot here. When x is 2, 2 squared turns out to be 4. So 2 comma 4 is a dot, and there's a corresponding dot here. If we wanted even another dot, it would be 3 comma 9 and negative 3 comma 9. Let's carefully draw in this parabola. Now that we've graphed y equals x squared, let's graph y equals 3. It's a horizontal line crossing the y-axis at 3. Notice the green parabola intersects the blue line at this dot and at this dot. The x-coordinates of these dots are the solution to this equation. They are the values for x that when you square them, you get the result of 3. We're going to take our best estimate from this graph. Go straight down from the blue dot until you see the numbers on the x-axis. It is between 1 and 2, and it looks a little more than halfway between 1 and 2. So I'm going to guess something more than 1.5. My guess is 1.7. Similarly, this blue dot, when you trace straight down to the x-axis, would be at negative 1.7. So I think these are the two solutions for x to this equation. Now on the same grid, let's figure out the answers for x such that when you square them, you get 7. I'm going to draw a horizontal line crossing the y-axis at 7. That horizontal blue line intersects the green parabola at this dot and at this dot. Let's find the x-coordinates of those dots. If you go straight downwards until you can read a number off the x-axis, approximately what number are we at? It's somewhere between 2 and 3, it's more than halfway, and it's fairly close to the 3. My estimate is going to be 2.8. And the x-coordinate of this dot on the left side, my estimate is going to be negative 2.8. If we were to solve the equation using algebra instead of graphing method, we would simply find the square root of 7. And that answer is about 2.64. So our estimate of 2.8 is close to 2.6, but it is a little bit off because we were using graphing method. Let's try number 3 the same way. First, substitute 0 for k, and then in the second question, 7 for k. And that creates these two equations. Let's solve these equations not with algebraic methods, but with graphing method. Take the left side of the equation and create a function out of it. Y equals x squared minus 4x plus 2. Then take the right side and create a function, y equals 0. This is a parabola. This is a horizontal line. Let's find where the parabola intersects that horizontal line. Okay, the equation of this parabola is in standard form. So we get the x-coordinate of the vertex using the formula negative b divided by 2a. That makes 4 over 2 times 1. which is 2. Then to get the y-coordinate of the vertex, substitute 2 into this equation. 2 squared makes 4. 4 times 2 makes 8. And then on the end, plus 2. 4 minus 8 is negative 4, and negative 4 plus 2 is negative 2. Our vertex is at 2, negative 2. That's located here. The value of A is a 1, just like in the parabola we graphed in number 1. So the pattern between the dots on the parabola are the same as that previous one. If you don't remember that pattern, go back and look at number 1. From the vertex, there was a dot here and here. It was like that you go right 1 and up 1, and left 1 and up 1. From this dot, there was another dot over 1 and up 3, and a corresponding dot here. If you like, you can even get another dot over 1, up 5, and a corresponding dot here. Let's graph this parabola. If you don't want to locate the dots in the parabola by recognizing patterns based on your experience, then you can always make an XY table. Once you know the vertex, that gets you the middle row of the table. Then choose numbers to the left of the vertex and to the right of the vertex and find these Y values. The point is, however, those are the dots that I found by recognizing patterns from my experience of graphing so many parabolas. That takes care of graphing the left side of the equation. Now let's draw a horizontal line crossing the y-axis at 0. Notice the horizontal line intersects the green parabola at this dot and at this dot. What are those x-coordinates? Let's make our best estimate. This one is somewhere between 0 and 1. It kind of looks halfway between. I think this is about 0.5. This dot is between 3 and 4, and it kind of looks about halfway in between. I'm going to guess 3.5. Here are my solutions in this equation for x. Now, the second question on number 3, it's the same parabola, it's just that the right side of the equation is 7. So we want to know, where does that parabola equal 7? Let's draw a horizontal line crossing through 7. Notice the green parabola crosses that line at this dot and at this dot. These are not in between the grid squares, so we can get accurate answers this time. X is negative 1, or this dot over here is where x is 5. Number 5, we have two quadratic equations. We know how to solve them using various algebra techniques, but we're asked to solve them with graphing. So take the left side of this equation and write it as a function, y equals x squared plus 5x. Take the right side and write it as its own function. This one makes a parabola, this one makes a horizontal line. Let's graph this parabola. It is in standard form. To get the x-coordinate of the vertex, the formula is negative b over 2a. That's negative 5 over 2 times 1, which is 2. This is negative 2.5. Now let's get the y-coordinate of the vertex by substituting negative 2.5 into this equation. And the result is negative 6.25. Let's locate that vertex dot. Here's negative 2.5 and then down 6.25. That's about right. The value of A is again a 1. So the pattern to the next dots is the same as we just had. Right 1 unit and up 1 unit. And a corresponding dot here. From this dot, right 1 unit, up 3. 1, 2, 3, and a corresponding dot here. From this dot, write 1 unit up 5. 1, 2, 3, 4, 5, and a corresponding dot here. Let's draw a parabola through this. That takes care of graphing this function. Now let's graph y equals 0, a horizontal line crossing the y-axis through 0. The blue line intersects the green parabola at this dot and at this dot. And these appear to have exact values of x, not decimals. I think that x is -5 or x is 0. By the way, if we had solved this with algebra, one technique is factoring. The left side factors as x times x plus 5 equals 0. Then when you solve this, you get 0, and when you solve in here, you get -5. So we can see that our graphical method is matching our algebraic methods from earlier this year. Okay, let's use that same green parabola, but this time locate a line at y equals -6. Horizontal line crossing the y-axis at -6. The green parabola appears to cross that here and here. Trace straight up until you can read the number off the x-axis, -3. And this dot here, straight up, it looks like -2. I think the answer for x is -3 or -2. Earlier this year, we solved the same equation using algebra methods. You would add the 6 to move it to the left side, creating a 0 on the right. Then factor this, x plus 3 times x plus 2. When you solve in here, you get -3, and when you solve in here, you get -2. So again, our graphical method is matching what we would get from our algebraic method. Number 7, we want to solve this using graphical method. So let's take the left side and write it as its own quadratic function. And then the right side will get y equals 0. This makes a parabola, but this one makes a line. To find that parabola, we need to know its vertex. So let's get the x-coordinate of the vertex using the formula -b divided by 2a. That's -6 divided by -6, which makes 1. Now to get the y-coordinate of the vertex, substitute 1 into that quadratic equation. 1 squared is 1, -3 times 1 is -3, 6 times 1 is 6, and on the end plus 1. This answer is 4. So the vertex of the parabola is 1, 4. When I look in front of x squared, the value of a is -3, not 1. So it doesn't follow the same pattern from dot to dot as the other parabolas we've graphed. Because it's negative, it goes downwards. And because it's a 3, it's going to go down 3 in that first move. Here's what I mean. Write 1 and then down 3. Here's a dot and here's a dot. Then over 1 and down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Down here. And a corresponding dot here. Here's the parabola. Now I'm going to graph a horizontal line crossing y equals 0. That blue line intersects the green line, here and here. What are the x-coordinates of those two dots? I'm going to take my best guesses on this one. It's between 2 and 3, but closer to the 2. I'm going to guess 2.2. This one here is between 0 and -1, but closer to the 0. I'm going to guess negative 0.2. For the second question, we're going to keep that same green parabola, but draw a horizontal line crossing negative 2. Here it is. The green parabola seems to cross that here and here. What are the x-coordinates of those dots? So take the dot and go straight up until you can read a number off the x-axis. Seems to be exactly halfway between 2 and 3. I'm going to guess 2.5. And for this dot, I'm going to guess negative 0.5. To know how close we were, we could solve that using algebra. Okay, number 9. This time we're going to graph an inequality involving a parabola. Because of this or equal to, we're going to draw a solid line, and because of the less than, we're going to shade under the boundary line. If we temporarily imagine this as an equals, then I hope you recognize y equals x squared is our most basic parabola. The vertex at 0, 0, in the pattern of the dots, over 1, up 1, and then over 1, up 3. If you were to do even another dot, you could go over 1, up 5. Now let's make a solid line through these dots. This is a is less than. Do you want to be above or below that boundary line? A less than means below. So shade everything under the parabola. Number 11, same thing. If you temporarily imagine this as an equals, then I hope you recognize y equals x squared minus 1 makes a parabola. The vertex is on the y-axis, but it's down at negative 1. The value of a is still a 1, so it's our normal pattern. Over 1, up 1, and then from this dot, over 1, up 3. There's no equals to bar, so this is a dashed boundary line. And this is a greater than, so you want to be above the boundary. That's these. Number 13. Let's change the order of this so the x squared term is first, then the x term. If this was an equals, this would be a parabola. And this has the look of standard form, where that's the a, that's the b. Let's get the x-coordinate of the vertex using negative b over 2a. So that's negative 2 over 2 times negative 1, which is negative 2. This is a 1. Now let's get the y-coordinate of the vertex by plugging in 1 into our equation. 1 squared is 1, and then a negative of that makes negative 1. And 2 times 1 is 2. This makes 1. The vertex is 1, 1. Let's find 1, 1 and mark it with a dot. The value of a is a negative 1. So the parabola opens downwards. From this vertex, over 1, down 1. And a corresponding dot here. From this dot, over 1, down 3. And a corresponding dot here. I'm using open dots because there's no or equal to symbol on this. I'm going to end up with a dashed boundary. Nothing on the boundary is actually a solution, so I don't really want to have regular dots on the boundary. This is a is less than, so shade under the boundary. Number 15, this is going to be another parabola with a solid boundary line and shading above. This is in standard form, so let's figure out the vertex. First, the x-coordinate of the vertex, negative b divided by 2a. The negative of negative 2 makes 2, and 2 times 1 makes 2. This turns out to be 1. Now get the y-coordinate of the vertex by plugging in 1. 1 squared makes 1. 2 times 1 makes a 2. And on the end, minus 3. So 1 minus 2 is negative 1 minus 3 is negative 4. 1 comma negative 4 is the vertex. The value of A is a 1. That is our normal pattern. Over 1, up 1. And from this dot, over 1, up 3. If you wanted even another dot, you'd go over 1, up 5. If you wanted another dot, you'd go over 1, up 7. Then over 1, up 9. Then over 1, up 11. Do you see the pattern whenever A is a 1? Let's draw a solid boundary line. This is a is greater than, so shade above the boundary. Number 17, I'm going to rearrange this so the terms are in the correct order. Negative x squared minus x plus 2. This is standard form. Let's get our vertex figured out. The negative of negative 1 makes 1. 2 times negative 1 makes negative 2. So we see our vertex is negative a half, or as a decimal, negative 0.5. Now let's get the y-coordinate of the vertex by plugging in negative 0.5 into our equation. The result is 2.25, or 2 1/4. Let's locate that vertex. Here's the origin. So left to negative 0.5, and then up 2 and an extra quarter. Here's the vertex dot. The value of A is negative 1. So the parabola opens down. From the vertex, right 1, down 1, and a corresponding dot here. From this dot, right 1, down 3, and a corresponding dot here. From this dot, right 1, down 5, 1, 2, 3, 4, 5, and a corresponding dot here. This has the equals bar on it, so a solid boundary. This is a is less than arrow, so underneath the boundary. Number 19, another parabola. We have standard form. This is A, B is a 1, and this is C. Let's get the x-coordinate of the vertex. Negative B divided by 2A. So negative 1 over 4. This is negative 1/4. Or as a decimal, negative 0.25, whichever way you prefer. Let's get the y-coordinate of the vertex by using the calculator. What I did was I typed this into my calculator, and where the x was, I filled in negative 0.25. The calculator tells me 5.875. Let's find that vertex. So right here is the origin. Negative 1/4 is a little bit to the left, not even halfway to the negative 1, just a little bit to the left. And then 5.8 is up here, not quite to the height of 6. Now I'm going to look at the value of A. It's a 2. So you know that normal pattern where I go over 1, up 1? I'm going to double the amount of vertical change. From the vertex dot, I'm going to go over 1, but then up 2. 1, 2, and a corresponding dot here. You know how normally from this dot you'd go over 1, up 3? I'm going to double the vertical change. I'm going to go over 1, up 6. 1, 2, 3, 4, 5, 6, and a corresponding dot here. This has an equals line on it, so it's a solid boundary. This is a is less than symbol, so shade under the boundary. Number 21, we have a system. One is a parabola, the other is a line. Let's graph both of them, starting with the parabola. This is our most basic parabola, where the vertex is at 0, 0. The value of A is a 1, so that's our normal rate of change. Over 1, up 1, and from this dot, over 1, up 3. This has the equals bar, so it's a solid boundary. This is a greater than, we want to be above the parabola. I'm not going to do the shading until after I draw my other function. Okay, now let's look at this next one. If this was y equals 2, it would be a horizontal line crossing 2. Let's draw a horizontal line, but because there's no equals, we'll make it dashed. This is a is less than, so we want to be under the dashed line. Do you remember earlier we wanted to be above the parabola? Under the dashed line, but above the parabola, is this small section of space in here. Number 23, same thing. We have a parabola and then a horizontal line. Let's do this parabola first. The first thing I'm going to do on it, though, is rearrange it so the x squared comes first and then the plus 4 is on the end. That helps me recognize what it looks like. The vertex is on the y-axis at 4. The value of A is negative, so it opens down. Over 1, down 1. And from this dot, over 1, down 3. There is this little line, so it is a solid boundary. This is a is less than, so we're going to be under that when we do the shading. Now before we shade anything, let's graph this line. It is a solid line, and it's crossing the y-axis at -1. Under the parabola, but above the line. That's this region of space. And finally, 25. We have a parabola, then a diagonal line. For the parabola, I'm going to rewrite it so that my x squared term is first, and then my x term. This is the start of standard form. Let's find the vertex of that using negative b over 2a. So the negative of 4 is -4. And then 2 times -1 is -2. This makes 2. Now the y-coordinate of the vertex. Plug a 2 into that formula. 2 squared is 4, and in front of that is negative, so -4. And 4 times 2 makes 8. This result is 4. 2, 4 is the vertex dot. Now look here in front of x squared. For our a value, it's -1. So it opens down. Over 1, down 1. From this dot, over 1, down 3. If you want another one, go over 1, down 5. This has the equals line, so it's solid. This is a less than, so we're going to go under that parabola. Before I shade it, let's take a look at this right here. This is slope-intercept form for a diagonal line, where the value of m is a 1, and on the end it's like having +0. You remember y equals mx plus b? So the y-intercept is 0, and the slope is up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Solid or dashed here? That's dashed. This is a is greater than. We want to be above the dashed line and under the parabola. Where is that? That's this small region of space in here.